Hi, and welcome to this video blog stream about interfaces. It's called Fun with Interfaces, and I got inspiration apparently from Dr. Sheldon Cooper. So I hope this is going to be more fun than Sheldon Cooper's viewers had with his stream. So let me cut straight to the chase. All of my demos today can be found at this GitHub, and actually, I apologize. This GitHub is still actually private. Allow me to switch it to public. And this is not going to work. Actually, let's do it like this. Give me 5 seconds. I really apologize for this. Probably by 15th stream, I won't be doing these mistakes. So my repo is now public. Can you actually see this? That it's actually public. I'm actually going to just quickly verify. I apologize. Yeah, so you can all access this URL now, and all of my demos are there, and all of different demos are in different branches. And if you have ever followed me on any of my, sorry, I have forgotten to show you the URL. So the URL is actually here, and if you have followed my demos so far, you know that I like to put demos in different branches. So every different branch is a different stage of the demo. So let's immediately go into demo 1. And while on this demo, I'm actually going to present everything. So before I explain what interfaces are and how we can use them to solve our daily problems, or how we can identify if we even have a problem that can be solved by interfaces, let's take a look at this extremely simple repo where I have 3 code units. One code unit is called cat, and cat says meow, dog says woof, and duck says quack. So not much of excitement yet, but please bear with me. We are going to get really deep, complex today. So this is just a very simple example so that you can all follow what's going on. In fact, yes, I apologize. I'm still talking to the camera. You're still not looking at my screen. Yeah, so now my screen should be here. So again, a cat, a dog, and a duck. And all of them do something specific for them. And then there is a code unit, which is called pick your pet. When you run this code unit, it calls this method make sound. Before it calls it, it shows a string menu and offers me these 3 options. And then based on which option you choose, it will run either dog.woof, cat.meow, or duck.quack. So this is, in essence, a very good starting point into understanding what interfaces are. So how can we recognize if we actually can have interfaces in our code? Well, there is the first thing that, first you need to answer a couple of questions. The first question is there something in common? So are there things in common when you look at, for example, this piece of code? So apparently, yes, all of them do something, and I could say they all make a sound. That's what the method at least is called. So I could say that all of these three have something in common that they can do that is similar to each other, but still specifically it's different. And then there is another question. And this other question is that the consumer does not care exactly about the specifics of how those objects that have something in common will actually perform their action. And then when we look in this code, we can actually see that, yes, true, the consumer, this code unit which calls make sound, it doesn't really care about how exactly does dog woof, or how exactly does cat meows, or how the duck quacks. So this is the starting point. And we can see that this very interface, the one that we have actually just, sorry, not interface, this piece of code is a perfect candidate for interfaces. So let's jump into demo number 2, and you can follow with me if you open demo number 2 branch as well. So I am now doing something very specific to interfaces. So interfaces are all about polymorphism, and polymorphism is a concept in programming where an object can take multiple shapes, and whoever consumes those different shapes, that code doesn't care about the specifics of a shape. It cares about only one aspect of that shape. And this is precisely what we have here. We had 3 animals, all of which can make a sound, but each of them makes it in a different way. So what I have done is I have added an animal interface, and this interface now has a method called makeSound. And I have done something to modify my cat, dog, and duck code unit. So all of them had a very specific method. Now all of them implement this interface, and all of them have this makeSound method. So I've replaced dog.woof, cat.meow. So now it's called makeSound, and it's an implementation of the iDemo animal interface. Interfaces often work with some kind of a pattern. So when you need to consume an interface, you need to look into, or you need to typically provide some kind of pattern which will substitute whatever you would have otherwise with an interface. So let's take a look at pick your pet. This pick your pet, in fact, calls this pet factory. And this pet factory is doing the following thing. So pet factory is in charge of mapping an option, in this case, unknown, if we press cancel, and we'll get back to that, dog, cat, or duck. And we return an interface. So what I'm doing inside my factory, and this is a typical interface pattern, is that I'm checking if this is a dog, I'm assigning dog to this pet, if it's a cat, cat, etc. So in essence, I have removed this factory out of my consumer code unit because the consumer doesn't need to have this logic. The consumer will call the factory here. It will create a pet based on the pet type that was returned from this str menu. And then it will call the makeSound function by passing the reference to an interface. And at this point, I'm going to run that. I didn't want to run the previous one because it was far too simple. So here I have pick your pet. I can say that it's a cat, and now it runs meow. I could have easily skipped this function. I could have easily just replaced this with pet.makeSound. But I didn't want to, because I wanted to show the beauty of interfaces and how we can actually do another thing with interfaces, which is yet another pattern, which is called inversion of control. And this is what I want to do here. So, but before we go there, let's take a look at a problem here. There is a big problem, and this is uninitialized interfaces, because if I go here and click pick your pet and then click cancel, I get a runtime error which says interface not initialized. And why is that? Well, it's actually very simple to follow. If I take a look at my pet factory only returns or assigns an interface or an actual code unit to the interface variable where I have an actual option. If I press cancel on str menu, it will be unknown option, and I'm not returning any interface. So in essence, this interface variable will be uninitialized at this point. So I'm just going to put it back as it was. So when I call pet factory with unknown and then pass this makeSound, here I'm going to get a runtime error. And this is the first big issue with interfaces, is that in AL you have no way to actually verify if an interface variable has been initialized or not. So there are more problems, and we will see some more of them today, but one of them, and the big one, is that you cannot check. So you have to apply some kind of pattern, maybe not call this factory if it will not return an interface, or maybe have another one like similar to handle pattern where you will check if it was handled, and if not, then you assume that no, or actually you know that no interface was assigned. But for now you need to know that yes, interfaces can be unassigned, and when they're unassigned you cannot know. Let's take a look at, actually I'm going to roll back my changes. I don't know what I changed, but I don't want to change anything. So let's take a look at the next demo. And so in this demo, I'm going to do one very nice thing in AL, or actually a very advisable thing in AL. I'm actually going to replace these options with enums. Enum is an AL type. You have seen that Microsoft has started replacing a lot of options with enums, and you should do the same. So let's take a look at what I have here. So I have now introduced this animal type enum, and then inside of my pet factory, I'm depending on that enum now, not on an option. And inside of my pick your pet, I'm simply retrieving pet type as an option. This is strange. Oh yeah, because it's assignment compatible. Actually, I can try running this. Okay, let me actually just close my folder and reopen it again. So yeah, I was looking at the wrong version of code. So my pick your pet code unit now is, first it's handling this 0 selection. I don't want that one. And the second one is that instead of option type, I have pet type, which is enum type. And this pet type, I actually use the enum and I specify which enum. So this is a global, just like code unit or database or any other object where you can also reference all of enums using this enum global. And then from this global enum, I use from integer. So I map the selection into a pet type. So depending on which option I clicked, I'm going to use the definition of this enum, which has values 1, 2, and 3. 0 I do not need because it is unknown. I'm not ever going to use that one. And then I'm calling pet factory with this pet type. Everything else is exactly the same. Nothing else has changed. So we don't really need to be looking into anything else. So if I run, it will just do exactly the same thing. What I want to go into is I want to move into next demo, which will show why we even went into enums, why we even cared about doing that, apart from that being an AL thing. So I'll first look this animal type enum, and what has changed here in branch demo 4 is that it now implements demo animal, and this is my interface. And then for each of values I have specified which code unit implements that. So in essence what I have said is that whenever I'm using animal type dog, I can use this code unit to represent this interface. And how can I actually use that? Again, from my pick your pet code unit. So inside my pick your pet code unit, I now have pet type. You can see I do not have pet anymore. I don't care. So another thing, my factory is gone. I don't need my factory again. What I'm doing is I'm retrieving pet type from my integer, and then I'm passing that pet type. So pet type is enum, as you can see, it's not an interface. I'm passing it to my makeSound method. But makeSound method didn't change. MakeSound method is still receiving an interface. So when you have an enum variable, you can assign that to an interface variable. So that's what I'm doing here. I'm assigning pet type, which is an enum, into an interface. And the compiler knows that if I pass cat, that it will be the cat code unit that will respond to this makeSound. So let me actually run this, and I'm going to put a breakpoint in here, and let's take a look. So if I click duck, for example, I should actually be here. I can see that pet is now, well, it's an interface. But if I look at the call stack, here pet type is an enum duck. So not only enums are assignment compatible to interfaces that they implement, but enums are actually the reason, the whole original idea why Microsoft has even implemented interface. Community has been asking for interfaces in code units for a lot of time, but Microsoft simply didn't see why we would need that. And then they realized that if we attach enums to, interfaces to enums, what we can do is in essence address one simple pattern that all of interfaces probably use, which is factory pattern. As you can see, my code doesn't have one anymore because every enum is an implicit factory. So previously my factory code unit had a case block. When you have enums, you don't need that case block. In essence, this is your entire case block. With this enum definition, you simply say case dog, code unit this, case cat, code unit this. So this is how enums solve these problems with factories and interfaces and make it very easy to design all of this polymorphic behavior that you can think of. So a couple of more things I want to do here is I want to replace this str menu with something else. I want to actually put a page which shows an option. So I'm going to demo 5, and here I now have this pick your pet page, which is nothing but a page that shows an option and returns that option. And for my pick your pet code unit, I first pick my pet, and if I do successfully pick my pet, then animal type will be enum, but I pass it to my make sound, which still receives an interface. Let's see the difference between this and the previous one. So when I click pick your pet, what I can see here is that now I don't have a radio list, I have a drop-down button. So when I click cat, I can click OK, and the cat says meow. So why is this important? Well, it's important because enums have a nice property to them, which is they are extensible. So here I have marked this enum as extensible, which means that if I have a extension which would depend on this extension, and actually I do have that extension, and it's my demo06, it's simply an extension which depends on my original one, and then it has simply extended my animal type. It has added another animal type, which is bird, and it has bird code unit, which says chirp. And then, of course, to be able to compile, I need to move this into AL packages. So I will move that. And now I'm going to run this code unit to see what has happened by me simply adding this depending code unit and simply extending an enum and attaching a code unit to that enum. So when I pick my pet, I now have bird, and when I click bird, it says chirp. So this was the introduction into interfaces. This has shown you how simple interfaces are, how amazingly beautiful they can be when you attach them to enums, and how you can easily call business logic behind those enums, like different price calculation, different behavior for different account types, etc. So let's now take a look at a more real-life example. So for that, I have prepared a couple of code units. So let me close this and this. Okay. First, I will delete this app. I don't want it to interfere with anything I do from now on. I'm going to close. Actually, I'm going to open polymorphic 01, and then I'm going to close the folder and reopen it again just to clear all of AL caches. So what do we have here? Let me start from this order processor, which I extend with this code unit demo new account. So instead of pick your pet, I have create new, and when I click this create new, again I have str menu, and it will ask me what account type I want to create. And then when I create an account, when I pick which account I want to create, I run code unit new customer or new vendor, or new employee. Before I look into these code units, let me actually run this and show you what happens. I'm going to delete this and delete this, and this is very strange, but yeah, now it works. Okay, so yes, the page is now open. I have it here. I can click create new, and then let's imagine we have this business process. When we want to create any of these three types of accounts, we want some checks to be made. So for example, when I want to create a new customer, I can click new customer, and then is solvency okay? Is key account manager selected? And if yes, then who is it? Waldo, for example. And then is contract signed? Yes, I have to approve that, and only then I can click on and proceed with whatever happens. It doesn't really matter what happens from this moment on. But imagine we have a process like this. So there are some features here. So first, when I run this demo new account, I will run one of these three, and then all of these three, like new customer, and let's take a look at new customer. I will start from here. It will first populate this demo precondition table. This precondition table contains the details about my preconditions. So code, description, and whether or not it has been satisfied. So I populate this precondition table, and then I run this check precondition page with this precondition. So when I run this page, it's really not rocket science. What is important here is that when you click a checkbox to validate in the onValidated trigger, I'm running this event on satisfy precondition to actually invoke my, and I'm going to keep this page open, to invoke my, for example, customer code unit, the satisfy precondition event subscriber, to make sure that I provide the business logic. So when you click, and as you have seen, when you click one of those checkboxes, what you want to do is you want to perform a specific business logic. So maybe for solvency check, yes, you just want to confirm or actually put checkbox in there. But for contract, you want to actually have a confirmation. Or for a key account manager, you actually want a user to make some input. So this subscriber provides that functionality. And it's a part of my new customer code unit because that's new customer business logic. My check preconditions page needs to have a way to invoke that. And I actually pulled a very old trick from my head, which is events. They have been around for 4 years or so. So this is a typical way how we would solve this problem. But let's now try to having seen this, let's try to figure out if there is anything where we could put, actually put interfaces. So for that, I'm going to open this one. Again, the first question we need to answer is there something in common? And then we can say, yes, absolutely. All of them do exactly the same thing. All of them define some preconditions, and all of them, apparently the employee does the same and vendor does the same. So all of them define some preconditions, and all of them actually run that check precondition page and then respond to those events. So absolutely there is something in common. And then does this feature care about which one of accounts it is going to create? It does not. It actually just does this case block to run the correct one. But once it runs it, it doesn't care what exactly it will do on the inside. So a perfect example for interfaces, and let's introduce interfaces into this. But before I do that, I'm going to go into my polymorphic 02, and I'm going to show you the big problem of all event pattern based bindings. In this case, we have a very loose binding between page and the code unit that the page should run, and that loose binding allows so-called rogue subscribers. I have a rogue subscriber here. So this subscriber doesn't do any check if it's this subscriber that needs to respond, like new customer does. It first checks what is the precondition I want to validate. The rogue subscriber simply says that satisfied is true. And when I run that, and then click create new and then customer, and then click key account, or let's say contract signed, and I click no, this will still get checked. That's because my rogue subscriber has hit in and has stolen the process. And this is something we don't want. And again, this is something that interfaces can solve. And then while solving that, we will first see and get totally excited, wow, how this is cool. Interfaces can totally solve this problem. And then when we start optimizing, we'll see that, yeah, interfaces really lack something. But let's get there step by step. So I'm going back to my code. I'm going to my branch go polymorphic 03. And here, I don't have my rogue subscriber anymore. It will never, ever happen. So what I have done in this branch is that I have introduced the enum. So I have the enum account type, and this enum account type now also responds to this, or actually implements this demo I new account interface. So let's take a look at that interface. Interface simply has one single method, which is called create new, and then my account type maps this, and this is the same old example about pets that we have just seen, except that this time we are using something more business central like. So I have account type, which is customer, vendor, and employee, and I still use exactly the same demo new customer, demo new vendor, etc. code units. So when I take a look at my, for example, demo new customer, what has changed here is that I don't have the on-run trigger. I have implementation of the interface, and I now respond to simply this create new method, which is an interface method. My new account code unit looks a little bit different. So I have a try function here. That's simply because this is the easiest trick to get around interface variable has no instance error that you've seen earlier. So here I map an integer to a new account, and if it fails, it will return false, so I will exit out of this. So I'm not going to say this is a pattern. It's certainly not an anti-pattern. It's something that helps you just map an interface into, let's say, a Boolean. So by using this try function, I'm saying if this does not end up mapping to an actual code unit that implements the interface, simply return false and get out. So this is how I've solved that problem. And then when I have this new account, the account is variable of type interface, even though I assign an enum to it. We know why that works the way it works. And I return it out, and then I call create new on this. And of course, when I run that, no wonder it will actually work. So when I click create new and then click, for example, new employee, I have different checks I need to do and perform. And yeah, so this is my first example where I actually have interfaces in place. What else can we do here? Is there anything else we can do to improve this? Well, first of all, if we look into these code units, customer and employee and vendor, all of them have some boilerplate. It's not much boilerplate, but it can actually grow very much. And this is this. So it can be a lot more. All of them run exactly the same chunk of code. Yeah, well, this is kind of boilerplate, not really, but this is happening in all of them. So I don't want my code units to do that. And then there is another one. We have this loose binding. So I do not want that. What I want is for my check preconditions page to have a way to talk to the code unit which implements the interface on which I'm currently working. So if it's customer, I want this page to be able to talk to customer code unit. And if it's vendor, I want it to be able to talk to vendor code unit. So let's take a look at demo 04. I'm going to open the interface and I will show what I've done to the interface to accommodate these requirements. So first, I have replaced the get create new. All of them create new. So I don't want that in there. What they have different is that they have different preconditions and different ways of checking those preconditions. So if I take a look at, for example, new customer code unit, now I have get preconditions. I still use this precondition table, and I define those preconditions in that table. However, my check precondition is now not an event subscriber anymore. It's now a function on the interface. So what does my new account code unit do? Well, first of all, it still retrieves this interface from the enum, and it calls my check method on check precondition page. However, this time it's not passing, actually, yeah, it is passing this entire interface, but I'm storing this interface in there. I'm storing the reference to this interface. And I'm actually going to call this interface when I want to check preconditions. So there is no more rogue subscribers because now there is no loose binding. My interfaces allow me to have a very strict, tight binding between consumer of a business logic and the business logic itself. So of course, when I run that, it will have exactly the same effect, except it will be a little bit better because now I cannot have rogue subscribers. So this is my vendor, and when I click my employee, this is my employee, and then of course this is exactly the same behavior as earlier, which means that my my employee check precondition has responded. In fact, I want that you to see that, so I'm going to choose employee, and I'm going to choose this one. It's not stopping on my breakpoint. I have this problem sometimes. Doesn't want me to add the breakpoint. Well, never mind. I'm just going to. Yeah, of course, because I didn't run this yet. So let me run this. Create new employee. Let's put a breakpoint in both customer and employee. Okay, but the breakpoint is not being set. Anyway, I don't really see why it's not happening, and I'm not going to investigate. I don't have time for that. But if this was an event, both would respond. And since it's not an event, it's specifically calling the specific implementation, it will just be employee that responds. I don't know why the breakpoint is not set. But in any case, this is the improvement that we have done. So, is there anything else that we can improve? Can we do something better? Like if looking at this check precondition and then employee check precondition, do we see something else where we can improve with the help of interfaces? And I would say yes, because anytime you see case, you should think in terms of maybe I can put enum there, maybe I can put at least interfaces with some kind of a factory behind. So all of them, customers, and employees and vendors, they are running similar checks. They either return true, they run a confirm, or they run a pop-up that asks a question. So instead of that, I want to have interfaces there. So let's take a look at how I have achieved that. I have my polymorphic 5 branch, which shows exactly this. So when looking at this, and now I have quite some restructuring. So since there is a lot of cache from earlier in memory, I'm going to close this folder and open the folder again so that my compiler doesn't complain. What do I have here? First of all, I have moved all of my account types in here. Everything is the same except that it's inside a new subfolder so that it's grouped nicely together. But I have new subfolder with preconditions. And I have done a couple of things. First of all, I have introduced precondition type. And this is an enum, which implements the iPrecondition interface. And this iPrecondition interface has one single method, which is called check. So for every precondition, no matter what it is, I can check that precondition. And then I have apparently bound different kinds of precondition, click precondition, confirm precondition, and question precondition to different enums. I've also extended my precondition table. I have added this enum here, and I have made sure that my define precondition function inside of my precondition table actually receives enum now and stores this enum. So if I take a look at, for example, customer, I have commented this out because I don't need that anymore. So this is gone for good. What I've done is I've simply defined these preconditions. I've defined solvency precondition, which is of click type. I have key account precondition, which is of question type, contract, which is of confirm type. And the same for all three code units. Then what else have I done? Simply, if I look into my preconditions, I have confirm precondition code unit. I have question precondition code unit and click precondition code unit. All of them implement this I precondition, have method called check, perform whatever they need to do, and return their result to the caller. And then from my caller, what I have done here is I have used record.type, which is of enum type, and I have assigned it to this interface. And I call this check on this interface. And then when I run this, we can click create new, and then I can click, for example, let's stay with customer, and I click solvency OK. Wow, fantastic, it works. But when I click contract signed, suddenly this is blank. And then when I click this one, it also doesn't show me the question that it used to show earlier. So what's wrong here? And if you got excited or too excited too early, then let me break the excitement by saying that yes, interfaces work amazingly nice with enums, but they have a very big problem there, and that problem is that they are simply static. So when you have this rec.type and it says that this is demo precondition type, this precondition type simply maps a code unit. But you can see this demo confirm code unit has some context. And I'm going to keep this open. And demo question precondition also has some context that it uses when performing its business logic. So how do I make sure that I can pass this context, or in short, to call this initialize function on an instance of this enum, or at least on an instance of this? Well, you cannot. And this is one of big problems with enum implementation of interfaces. When Microsoft has designed interfaces, as I said, they have designed them with enums in mind. And enums are static, just like event subscribers are primarily static. And while with event subscribers, at least you can choose for a code unit to subscribe manually or explicitly, with enums, it's a little bit different. You cannot explicitly pass an instance of a code unit, nor can you control an instance of a code unit which is handling a specific method. So this is a big problem with enums, and we need to fix that. So I'm going to stop this branch, this code, and I'm going to switch to the polymorphic 6 branch, where I'm solving this problem. So now I'm not going to check precondition inside my precondition interface. I'm simply going to initialize that. And that initialize will pass this description. Let's take a look at these code units which implement it. So for example, question precondition. It has this initialize, it receives this description, and this description is what is going to be shown in the check precondition page. Let's take a look at, for example, how now this is being called. So if I look at my account type interface, I have removed one function from here, so I'm not checking preconditions there anymore. I have just configure preconditions now. So how do I implement my customers? I'm going to close this folder and reopen again. It has too many compilation errors. Okay, so new customer. Let's take a look. It responds to configure preconditions. And inside configure preconditions, it now does something different. It applies a factory pattern with preconditions. And preconditions are not going to be primarily the table anymore. So as you can see here, I'm not handling precondition table here to populate it with preconditions. I'm simply using 3 code units or 3 interface references, and I use this demo precondition factory to assign a specific precondition. And then let's take a look at this click precondition inside my factory code unit. So my factory handles specifics of each different kind of precondition it can handle. So since I can handle click precondition, confirm precondition, and question precondition, these 3 different precondition types all have different implementation code units, which have something in common, but also have something in different from one another. So I will return an interface from all 3 of them, as you can see. But inside of the first one, I simply have click precondition. In the second one, I have confirm precondition. But I have one extra parameter, and I pass this parameter into the set question of confirm precondition. So by that, I can control which specific instance will run, and I can make sure that this instance is running at that time. However, I will not be able to pass those instances, those 3 different instances from this customer code unit to my page, because again, the page has no way of addressing or accessing preconditions, or sorry, not preconditions, code units, or an unknown list of code units contained somewhere else. I have 3 preconditions here, but I have 5 preconditions here. There is no collection in AL which can hold these. Yes, there is array of interface, but then I have to set an upper limit. And if I, for whatever reason, exceed this upper limit, my code will break. And if I have a ridiculously high upper limit, I'm probably going to just run into, well, it's first not a good thing. You should not just accumulate or define arrays to hold variable length entities like preconditions in this case. And the second, you may run into issues with memory because you need to hold too many references to interfaces. So I have this factory which defines my precondition. Then I store the reference to each 3 of created precondition code units. My page is now doing something else. My page now does not receive will not ask my interface to provide preconditions. It will simply discover preconditions. And this is something new. So I have this discover precondition event, and all of my precondition code units have discovery. So they will all respond to the discovery method, and then they will pass the description into the table. So since I'm running discovery from the table, when I run this, all of them will call sender.discover, they will pass description, and they will receive a GUID. Why GUID? Because it's a unique thing. I pass a unique GUID to each code unit which has been discovered, and inside of, for example, question precondition, when I respond to the discovery, I store this GUID. And then there is another event. I've fallen back to event-driven checking. And this is unfortunate, but as I said, because of all those limitations with interfaces, I didn't have any other option. I had to pull to actually plug in events, but at least I have made them manual bound. So my factory, precondition factory, where is it? Here, my factory code unit binds the subscription for every instance. And this bind subscription will make sure that when I want to discover preconditions from page on run, or when I want to check a precondition from the onValidate trigger, and this is again going to run this event, that my manually bound instance will respond. So I first map a specific code unit to that interface, and then I bind that that code unit to events. And I'm going back to my factory to address this problem. If bind subscription worked in a different way, for example, if I was able to bind subscription from within here by simply saying bind subscription, I wouldn't have to do that. I wouldn't even have to do any of the, like this check could be even done from here, or discovery, or I could even bind these explicitly. So the thing is, I cannot do that. And why can I not do that? Because bind subscription requires a reference. And for me to be able to bind reference, I want to bind this reference. And normal languages like C#, they have this, or Visual Basic has me, or there are languages which have self. AL has nothing. You cannot bind this instance to something. So to solve that problem, my factory, in essence, is passing, or actually taking care of that. So I'm doing it from within factory rather than from the precondition code unit. It would be far better if my precondition code unit could actually do binding and say, okay, I'm now binding myself to whatever events I should be bound to. Unfortunately, we cannot do that with AL. And then, yeah, we have this problem. But still, you know, when I run this, it will run nicely. and all of this will happen correctly, and there will be only one code unit that will respond to all of these. So when I click vendor, and I click prices are acceptable, legal review, I confirm. You see, it's now a concrete one because it's my explicitly bound instance of a code unit which carries that state with it. It's not something bound to an enum statically that responds here, so I can fully control all of the state. Then let's take a look at something else. So I'm going into the next variation of this, which is polymorphic 7 branch, and this is almost the last branch that I wanted to show. I'm also going to close that, and I'm going to open it again. Oh no, I've closed everything, so opening it again. Here I have done something. I have, in essence, I have decided to go to new account code unit. So I have introduced yet another factory to allow me to respond to different kinds of account types. I've also added account type enum. So if we take a look at account types, we can see that I have, where is it? Sorry, no. I have not added enum. I've added GUID. What I apologize. I have simply got a little bit confused. So when I'm choosing which to run, I currently have this hard-coded customer, vendor, employee. I want to have discovery in that. I want to be able to plug in new account types as I want. So instead of simply offering an str menu, I first run account type factory. And this account type, check account type, I actually have a page. I apologize. This account type page let me run this, and then I will explain what's happening as it runs. So when I look at my choose account type page, it's simply offering a choice of account type I want to show. So here I have this record.description, and this record is, it's new account type table. So this new account type table contains description of account type I want to create and has a GUID. And it has discovery event. So this discovery event is going to be fired from my new account code unit. So I'm first going to run this from here. And then all of my account types code units will respond to this discovery in here. And then they will discover themselves. They will say, I can create customers, or I can create employees. And they will store a GUID. All of them have a hard-coded GUID by which they identify themselves. So after I discover them, I show this new account. Where is this page? Choose account type. I run that page, and I simply return a GUID that was chosen. So this is going to be GUID that was chosen. And then with that GUID, what I do is, if I go back to my new account, I use that GUID to run a factory method. So this is now a little bit strange because we have never seen this kind of factory before. But this is, in fact, an event-driven factory. So I'm running not a factory method, but in fact, I'm running a factory event. I'm passing the GUID of the chosen account type, and this new account is still an interface, and I'm asking these code units to say, okay, whichever code unit should respond to that one should also assign explicit implementation to this interface, and it should tell me if this was handled. So if I look at my new customer, for example, I respond to account type factory event, and I check if this GUID is the GUID that I have received. If not, I get out. If yes, I assigned handled, and I assigned this code unit, which is in essence simply just an extra reference to this code unit. And all of them do the same. So both, all of them check if there is a correct GUID and assign themselves. And then when I run that, as we can see, when I click this, I now have this table. And when I click vendor and click OK, I have this. And when I click employee, I have this. And this is again my preconditions, which have exactly the same event-driven functionality, but explicit interfaces behind them. And beauty of this is that now that I have actually completely taken this business logic apart into different interfaces, I can easily extend this by going into Polymorphic 8, which is nothing but an app. And I'm again going to move this into my AL packages. I'm going to restart it to show what's going on. And what I have here is, again, dependency on the previous version of this extension. And I have a new precondition type, which implements demo I precondition. So it's simply a new precondition variant. And I have new account type, which now implements or actually uses this string menu precondition. And I run this. Create new, and suddenly I have GL account. When I click this, I have a completely different kind of precondition check. So that's all I had to show. Except I wanted to say that this is not all there is to say about interfaces. This is probably just scratching the surface. This is simply showing the power and the limitations that you have, and actually how to think when figuring out if there is room for implementing interfaces in your solution, or which area of your application can be refactored or improved using interfaces. Interfaces are extremely useful in testability, for example, and we're going to take a look at that in one of the future video blogs. I'm definitely going to dedicate an entire session to this video blog. There are more examples in this repo that I've shown on my GitHub. You can actually use it to see how I have implemented interfaces in another real-life example of business logic in Business Central with interfaces. And with that said, let's actually move on to questions. Let me see if there are any questions. Where is my... Okay, no. Yeah. So, let me address the question. I didn't read everything since I was talking. I don't yet know a way how to make this more interactive, but yeah. So is Amy around? No, Amy is not around. It is working. Yeah, I'm Amy. Somebody says the sound is slightly asynchronous. Yes, I know. This is something that's happening, and I'm going to fix that. The problem is that my camera is not recording my sound. It's my microphone. And my microphone is not receiving, well, it's two inputs. And my streamer is simply not synchronizing them. I'm fixing that. I've ordered a cable to connect my microphone to my camera, and then actually this will be synchronized next week, I promise. So I'm really sorry that it is the way it is right now. Is this going to be an app on AppSource? No, but if you want to take my GitHub and make it an app, absolutely do meow, quack, and woof. Or pet source, no. Hello, looks like I'm not the only one getting the timeout error. And don't know what Waldo refers to here. Was just thinking the same, did countless number of reload window in VS Code. Yeah, apparently when you switch branches and there is breaking changes, compiler doesn't figure it out. So you need to either go individually into each file that has compilation errors after the change, or you need to close and reopen. I'm sorry, that's how it works. Some hellos, seems we need to learn him, Waldo. Reload window command, yeah, reload window command. I don't know that command, maybe I will learn about that command now. Yeah, teach, Waldo, good pick. What is the pattern? To make a new enum value that is almost identical to one of the existing enum values, and only wish to customize a few methods on the other enum value. Well, that's not possible. So this is again one of the limitations of both enums and the interfaces. So if you want to replace an interface for one of the enum values, you cannot do that. A trick that I'm not sure if I can really recommend that, because I didn't play that much in real life with that, but what I've done, and that's what my other demo does, there is one demo that I didn't demonstrate in my GitHub, is for a situation when standard enum doesn't have an interface. Then you can provide your own surrogate implementation. You, in essence, create exactly the same enum, make it assignment compatible, map the same value. So map the original value to the new one. You can see how I did that in my branch. And then you can use it as if it was, in fact, original enum with interface. And I assume you could use the same trick to provide surrogate implementation. So if you want to change how, for example, dog behaves on an existing interface or enum, you could do that by providing a surrogate interface. I'm shocked, Vieko. Why? I don't know. Because you don't know reload window. Yeah, sorry, I don't know reload window. I will learn that. There are things to learn every day, so this is my opportunity to learn something really useful today. Okay, any other questions? Something probably related to interfaces. Check Twitter. I'm going to check Twitter. Let me check Twitter. It takes time. Yeah. I'm checking Twitter. Okay, yeah, okay, fine. Nice. Thank you, Waldo. I will remember this. Developer reload. Okay. Do we have any more interface related questions? Not yet. I'm going to give you another minute. Let me ask you a question. Did this session answer your questions or address your curiosity about interfaces? Like, one of the reasons why I wanted to do that, I got feedback that interfaces are not documented enough or correctly on Microsoft documentation site. So does this session explain what the documentation does not? Yeah, you can leave comments. Thanks AJ. Glad. Okay, so then I didn't miss at least. Well, if there is anything else, you always know that you can ask questions on my Twitter or on my blog. You can also come here and I will answer in the comment section of this video when it's public. It was helpful for explaining how to do it, definitely. Now we all get to think about what business cases to use it for. Well, cats and dogs and ducks and birds. No, I'm kidding. There's a lot of places, like anytime you see a case statement, you should think, can I do something with interfaces here? And the answer is probably yes, you can. Or maybe anytime when you have an option, or especially case with an option, absolutely you can go for interfaces, and I believe you actually should. So, good. Well, I will now close this stream. It has ran for nearly an hour. I was aiming for half an hour, and I was aiming of showing more demos, but apparently, yeah, it took me more. So, thank you all for attending this. I hope you enjoyed this. Fun with interfaces. There will be fun with interfaces, or actually here, this way, fun with interfaces 2.0. Make sure to click the subscribe button somewhere down there, and also notify button. It's called something. Yeah, I'm not an expert at YouTube yet, so yeah. Please subscribe, please follow me, and see you next week. Thanks.